Humanoid robots have made splashy headlines in the consumer press since Honda's Asimo debuted in 2000, but operational units outside of the lab have remained extremely rare. Tesla's announcement of Optimus in 2021 drew attention, but progress appeared sluggish, until the spring of 2025, when two videos were released just 7 days apart. A playful dance on May 14th, followed by a home task performance on May 21st. The short interval between the two signals, a company eager to demonstrate momentum on both breadth with number of tasks and depth with autonomy within each task. For investors like us, the footage serves as real-time evidence that Optimus is moving beyond the experimental phase and entering the real-world functionality stage. So what exactly has the Tesla Bot Gen 3 accomplished? Can we truly place our trust in a robot to handle everyday household tasks proactively and independently, perhaps even more reliably than a human housekeeper? Welcome to the world of Tesla cars. So what updates is the Tesla Bot Optimus Gen 3 rolling out? Tesla's latest Optimus clip, titled, "I'm Not Just Dancing All Day, Okay," marks 66-second reel features 5 distinct household tasks: taking out the trash, brushing crumbs into a dustpan, tearing off a paper towel and wiping the table, stirring a pot on the stove, and vacuuming the floor. Each segment begins with a voice prompt recorded off-camera. There are no visible fiducial markers, QR codes, or scripted guide paths. While some footage is sped up 2 times, the raw clips still show stable foot placement, compliant arm trajectories, and finger articulation precise enough to separate a single sheet of paper towel. Whereas earlier demos relied on remote operation or discrete behavior modules, Tesla claims an end-to-end neural network powers the entire sequence. What does that mean? The cost of task switching is going down, a prerequisite for real-world work both at home and on the factory floor. Tesla Vice President Milan Kovic called this latest capability a significant breakthrough in transferring human demonstrations directly into robot policy, without the need for extensive teleop fine-tuning. The team's next milestone is to scale data collection to include third-party internet videos, followed by reinforcement learning practice in both simulation and the real world. This kind of pipeline reflects recent academic advances, such as diffusion policies for large action spaces and human-like imitation datasets, treating the internet as a near-limitless guidance buffer for embodied AI. If successful, Tesla could drastically reduce the per-task data collection cost, a major bottleneck long cited by rivals like Figure AI and Agility Robotics. Tesla's latest video opens with what appears to be a simple scene, a soft plastic trash bag resting on a chair. But from the very first movement, it's clear. This isn't just a routine mechanical action. Optimus approaches, using 3 fingers to grip the bag's thin edge, then executes a precise 38-degree wrist rotation, just enough to free the bag from where it clings to its arm and torso. It then shifts its grip to the gathered fabric, redistributing the force vertically, and gently places the bag into a swing-lid trash can. Quick, smooth, and precise. But the most remarkable aspects lie beneath the surface of this action. Optimus is simultaneously demonstrating 3 highly sophisticated technical capabilities, each long considered a true barrier in applied robotics, such as material inference. The robot recognizes that the bag is made of a deformable film, flexible, yet durable. More importantly, it understands that the material can withstand a strong grip, strong enough, in fact, that it could crush ceramic if misapplied. This reflects real-time physical reasoning and material assessment, far beyond the hard-coded routines used by most current robots. Dynamic grasp planning. While moving, Optimus doesn't hold a single static grip. Instead, it adjusts its grasp, recalculating its hold to keep its center of mass within its support polygon. This is critical for maintaining balance during movement, especially while performing arm tasks mid-step. Predictive collision avoidance. As its arm and elbow swing close to the trash can's lid, the robot actively adjusts its trajectory to avoid impact, not just reacting, but anticipating. This is model-based predictive control, a complex capability typically reserved for high-end robots working in human environments. Why does this matter? Because what you're seeing isn't just a cleaning robot, it's a real-world test of end-to-end policy learning. That means the robot isn't just executing pre-programmed steps, but learning entire behavior sequences, from perception to action, as a unified process. This is exactly what many academic projects in domestic or service robotics are still trying to model in theory. A small task, but a powerful signal of where Optimus is headed. True autonomy, real-world adaptability, and the ability to make decisions like an intelligent, embodied agent. In the next part of the demo, Optimus is assigned a task that seems simple on the surface: sweeping up breadcrumbs with a brush about 5 inches long and dumping them into a dustpan tilted at a 17-degree angle. It sounds straightforward, but in robotics, this is one of the toughest tests of force control in real-world environments. Why? Because the interaction between brush bristles and breadcrumbs generates entirely unpredictable feedback forces. The bristles don't move uniformly. The crumbs are irregular and stable. And every tiny collision influences the torque on the robot's arm. To handle this, Optimus can't rely on open-loop position control, the simple type that doesn't account for feedback. Instead, it has to modulate force and torque in real time, responding to signals like a living organism reacting on instinct. What makes this possible? The all-new Gen 3 hand. Unlike the previous Gen 2 version, which featured 11 degrees of freedom across the palm and fingers, the Gen 3 hand boasts 22 DOF, making it significantly more compliant, adaptive, and dexterous when dealing with uneven or delicate objects. This is the same hand that stunned viewers back in November 2024, when Tesla demoed it catching a tennis ball, a classic test for fast, precise force control. And as if to underline its progress in force handling, Optimus follows up with a deceptively delicate move: tearing a single sheet off a perforated paper towel roll. That might sound like a matter of simply pulling hard or soft, but it's not. Pull too slowly, and the sheet won't tear along the perforation. Pull too fast or unevenly, and the whole roll might unravel, or the sheet could tear off track. Optimus has to modulate its pulling speed just below the tear propagation threshold, solving a micro-level physics problem that's surprisingly complex. This is exactly the kind of development that has robotics researchers excited. It's no longer just about picking up and placing objects. This is real force control, what many consider the gateway for robots to graduate from industrial tasks to flexible domestic work. Cleaning, wiping, serving, even cooking. Because only when a robot can control force, not just position, can it begin to interact with the physical world the way humans do. Optimus is proving that's not only possible, it's happening. And if a robot can catch a tennis ball and cleanly tear off a paper towel, then, realistically, doing your dishes might just be a matter of time. The moment everyone's been waiting for has arrived. Optimus steps into the kitchen, and it's not just for show. The tomato soup stirring scene is a textbook example. One robotic arm grips the ladle firmly while the elbow rotates in a circular motion, not for flair, but to optimize stirring force based on the resistance of the liquid. As the viscosity increases, the radius of the elbow's motion automatically tightens. The ladle stays neatly inside the pot. No clanking edges, no slips. Meanwhile, Optimus's upper torso leans forward about 6 to 8 centimeters, a subtle but critical adjustment that keeps its center of pressure stable, even as it counters the shifting resistance of the soup. This reveals a central controller that's fusing data from positional sensors, contact force feedback, and depth information from onboard cameras, a form of full-body motion control akin to proprioception in humans. And if you think stirring soup is the main challenge, just wait until Optimus starts vacuuming under the table. This is where every technical layer begins to converge. The robot has to angle the vacuum nozzle toward hidden dust clusters, not just a matter of moving its arm, but a synthesis of SLAM, simultaneous localization and mapping, for spatial navigation, combined with rapid, centimeter-level wrist height adjustments at the nozzle. In short, it has to know where it is in space and place its hand precisely moment to moment, And here's the key takeaway. These scenes aren't just choreographed robot ballet. They check off all 7 categories of modern robotic manipulation, such as compression, grasping, tool use, force feedback integration, bimanual coordination, motion task coupling, continuous workspace coverage. This isn't a robot repeating the same task on a factory line. This is a robot that understands the task, senses the environment, and makes movement decisions like a being with motion awareness. How will we teach Tesla bot Optimus with video? Tesla is teaching Optimus the way humans learn, and it all starts with video. According to Milan Kovic, the head of the Optimus project, most of the robot's skills don't come from traditional teleoperation-style remote control. Instead, its policy is trained directly from first-person video footage, like what you'd get from a GoPro strapped to someone's head. In other words, you wipe down a kitchen counter, the robot watches that video, and then teaches itself how to wipe the counter. No engineers writing code, no labels, no need to track every joint. Just raw visual data and a large enough neural network to figure out what's going on. The payoff? Huge. First, it slashes the time and cost of supervision. Second, it massively accelerates the range of skills the robot can acquire. And third, it closes the gap between simulation and the real world far faster than competitors still relying on labeled datasets and offline processing pipelines. According to the latest reports, Optimus is now powered by a single neural network, a unified policy that governs its entire action sequence. That might sound ordinary, but in the robotics world, it's a giant leap. Why does having a single neural network matter so much? Because most robots today still operate using what's called a modular stack, breaking complex tasks into smaller chunks: visual recognition, planning, arm control, force feedback, and so on. Each module is handled by a separate system. It sounds logical, but in practice, these stacks often collapse at the seams, where input data or environmental conditions change just enough to throw the whole system off. Tesla, by contrast, is going all in on a monolithic policy, a single model that learns shared latent representations across many tasks. Instead of stitching modules together, it learns to understand situations in fluid, real-world contexts, just like a human would. While other systems are still trying to teach a robot how to wipe a table by writing thousands of lines of code or manually labeling key points in videos, Tesla is simply letting Optimus watch you work and learn by doing. This is observational learning in its purest form, and it could be the foundation for robots that one day teach themselves to master any task, no coding required. It all begins with a simple phrase: clear the table, or stir the pot. For Optimus, each of these commands is the starting point for an integrated chain of actions. A built-in voice recognition system first transcribes the spoken sentence. Then, the language is passed into a language-conditioned action encoder, which converts the command into a target vector, an actionable signal that guides the robot's entire behavior in context. For decades, the robotics industry has produced incredibly agile, precise, and capable machines. But most domestic robots, even high-profile ones like Honda's Asimo, have failed to gain traction in the market. Not because they lacked physical ability, but because they couldn't communicate in a way humans actually want. Put simply, the problem isn't the robot arm, it's the interaction friction. People don't want to learn a custom GUI or type commands into a digital control panel like they're operating lab equipment. They just want to say something and see it happen. If Optimus can turn a simple sentence into executable behavior, Tesla will have achieved what most service robotics companies are still struggling with: bypassing the custom user interface layer entirely and integrating robots into real life through natural language. That not only makes robots vastly more useful, but also slashes the barrier to entry for everyday users. A crucial factor if the goal is to put robots in homes, not just in labs. In a world where people want to say, "stir the soup," and see it happen without further explanation. Optimus is getting closer than ever to becoming the first robot that truly understands and serves humans, not through code, but through conversation. If you think holding a ladle, wiping a counter, or vacuuming under a table is just show and tell, think again. The home is not a friendly place for robots. It's an adversarial testing ground, full of soft, irregularly shaped objects, shifting lighting, pets darting around in a non-stop stream of non-repetitive tasks. Wipe this, grab that, open this lid, place something over there. There's no clear sequence, no rhythmic pace like a factory line. And that's exactly why Tesla's May 21st demo marks a significant milestone. It showed that Optimus has achieved three key technical pillars, three foundational requirements for any robot to move beyond the lab and become a real product. 1. Manipulation. Bandwidth. The Gen 3 hand, with its 22 degrees of freedom, paired with tactile servo control and visual feedback, delivers a level of dexterity and force responsiveness high enough to handle soft, slippery, or deformable objects, like trash bags or paper towels. 2. Contextual autonomy. A single monolithic neural network, no architectural changes needed, can now manage a wide range of unrelated tasks, from stirring soup to vacuuming, tearing paper to taking out the trash. No task-specific programming. No decomposing actions into hand-coded steps like in traditional robotics. 3. Human-friendly interface. Instead of scripting in an IDE or tweaking technical configs, the user just speaks, "Clear the table." And the robot listens, understands, and acts. It's the kind of user experience that previous generations of robots simply couldn't deliver. What about speed? Tesla has been upfront. Some clips in the video are shown at 2x speed. But that's not a weakness. It's a statement of reliability. In a household environment, people don't care if a robot finishes a task in 8 or 11 seconds. They care whether it finishes correctly and completely. How long do you think it'll be before a robot like Optimus shows up in your own kitchen? 3 years, 5 years, or never? If you could teach Optimus just one task using video, what would you want it to learn first? Please share your opinion in the comments section below the video. Every time Elon Musk talks about the human assistance potential of the Tesla bot Optimus, he often compares it to C3PO or R2-D2 from Star Wars. Musk believes that eventually, each of us will have our own personal robot like that. But as Tesla keeps rolling out impressive upgrades to the Optimus robot, it's also raising some concerns. Let's be honest, not everyone feels great about the idea of humanoid robots. A lot of people worry about a Terminator-style future, where robots become more powerful and intelligent than humans. Instead of being controlled by us, they could overpower us, or at the very least, take our jobs. That's not what Elon Musk says he's building. According to him, Tesla plans to make billions of these robots to help solve labor shortages. The idea is to free humans from repetitive tasks so we can focus on more creative and meaningful work. Lately, Musk has been releasing update after update showing how much Optimus is improving, with each new version moving better, becoming more agile, and handling tasks more skillfully than the last. One especially exciting development is Optimus's ability to handle dynamic, unpredictable movements. That kind of adaptability is huge when it comes to real-world use, whether it's working in a factory or doing household chores. These are environments that change constantly and require quick adjustments. And today's update? It's about Optimus's insane balance. That might sound simple, but balance is a huge deal. It could be the deciding factor in whether people are actually willing to buy this thing or not. Nobody wants a robot that takes 5 steps and falls over after 3. Or worse, one that keeps knocking over dishes with its wobbly walk. Yeah, balance is that important. Without it, a robot's pretty much useless when it comes to getting actual work done. Balance is one of the biggest challenges in developing humanoid robots. Unlike stationary industrial robots or wheeled robots, humanoids have to walk on 2 legs, mimicking how humans move in a 3-dimensional space. That kind of movement doesn't just require a complex mix of hardware and software working together. It also means the robot has to adapt to all kinds of uneven environments, from flat indoor floors to rough outdoor terrain. If a robot can't maintain good balance, it becomes pretty much useless in real-world situations. One fall could damage its hardware, interrupt its task, or even pose a safety risk to people nearby. On top of that, poor balance limits the robot's ability to perform more advanced tasks like carrying loads, climbing, or interacting with fast-changing surroundings. In reality, the situations that demand strong balance are everywhere. In industrial settings, a robot might need to walk across uneven surfaces, like factory floors, cluttered with cables, or construction sites with loose debris. In a home, it might have to climb stairs, step over objects on the floor, or stay upright if it gets bumped. In rescue missions, it could need to balance on rubble or rugged terrain just to reach a victim. Without exceptional balance, a humanoid robot just can't replace or reliably assist humans in these scenarios. That really limits its practical value. You can see that the acrobatic stunts performed by Boston Dynamics Atlas have earned the robot a lot of praise. They're a clear demonstration of its agility and flexibility. To really highlight Optimus's insanely impressive balance, let's take a look back at the two most revealing videos showcasing this ability. The first one came out in December 2024, showing Optimus being tested on a steep, gravel-covered hill. The robot had to walk both up and down this uneven terrain. At the time, its gait looked pretty wobbly, kind of like a drunk guy stumbling around. But that doesn't take away from what it actually pulled off. Optimus showed a level of balance that went way beyond what anyone expected. Milan Kovac, VP of Engineering for Optimus, said the slope was covered in mulch, and even he slipped and fell on it. Yet Optimus handled it like it was no big deal. Even with that unsteady-looking walk, Optimus managed to go uphill and downhill without falling. Technically, that gait may help it lower its center of gravity, but that's not what made this video impressive. The real standout moment was when Optimus slipped and nearly fell backward, but instead of going down, it quickly reacted and recovered its balance. If you watch closely, you'll notice how its arms and legs responded in a way that looked surprisingly human. This kind of self-correction is a major breakthrough. It shows that Optimus isn't just blindly following pre-programmed movements. It can respond to unexpected situations in real time. What's more, Elon Musk confirmed that Optimus was operating in blindfolded mode during the test, meaning it couldn't actually see the terrain. That makes it even more impressive, revealing just how advanced its sensors and neural networks are. Then there's the most recent video, which showed Optimus performing complex dance moves, ballet, street dance, and spins, right on the factory floor. At first glance, it might look like just a cool performance, but if you look more closely, you'll see it marks a major leap in Optimus's balance capabilities. The robot pulled off coordinated spins, jumps, and fluid dance motions with no external support. That's a clear sign that its control systems and sensors have reached a whole new level of sophistication. These movements require constant and rapid shifts in center of gravity, yet Optimus was able to stay balanced without any external support. That proves its control system can process real-time data with high precision, coordinating connections and motor outputs to keep the robot stable. To achieve this impressive level of balance, Tesla has packed Optimus with a range of cutting-edge technologies, blending hardware and AI software. First, there's the sensor system and physical hardware. Optimus is equipped with sensors like an inertial measurement unit to track velocity and orientation, along with force sensors in its feet to detect pressure and friction on the ground. That's why, when moving across flat surfaces like a factory floor, Optimus walks with less knee bending and has a more natural gait. Powerful servo motors at its joints allow it to make fast adjustments, maintaining posture even during sudden shifts in movement. The fact that Optimus performs in both videos without any physical support shows just how independently it can operate. Its movements aren't being stabilized by cables or rigs. Everything is self-balanced. Normally, a robot attempting those kinds of dance moves would need to be tethered to prevent falls. Clearly, Tesla has overcome some major engineering challenges here. Second, a big part of what makes Optimus so stable is its AI, especially the neural networks that Tesla has spent years developing. The company applied its expertise from autonomous driving to build the real brain behind Optimus.
And Tesla has some important missing ingredients that others don't have, which is our robot has a real brain. It's like the Wizard of Oz.
In the hill climbing video, Milan Kovac revealed that the robot wasn't relying on vision to move. Instead, it used neural networks to control limb movements, predicting and adapting its motion based on the terrain in real time. Basically, even if Optimus's 2D cameras, the ones acting as its eyes, aren't functioning, it can still move smoothly by relying on the sensors built into its body. Sensors in its feet feel the ground, whether it's dirt, grass, or gravel, and send that data to its onboard brain. Then, the system analyzes that information almost instantly and decides the best speed and movement pattern, just like how a human adjusts when walking on unfamiliar terrain.
It's got the real-world AI, so Tesla's the leader in real-world AI. What we learned in the car, we translate to the Optimus robot. And we also take our expertise in electric motors, in batteries, power electronics, structural design. And then another major important thing is that we're very good at manufacturing.
When Optimus climbs stairs, it doesn't need a human to control it remotely. It handles everything on its own. The robot is equipped with ultra-sensitive sensors all over its body, including force and acceleration sensors, which constantly gather data about the stairs. Things like step height, slipperiness, and shape. Within just 2 to 3 milliseconds, this data is sent to its AI brain, where neural networks instantly process the information and make real-time decisions. How to place each foot, how to shift weight, and how to avoid slipping. The result, smooth, stable steps, even if it's not quite as fluid as a human yet. What's even more incredible is how this skill was developed, through millions of simulated scenarios. Tesla trained Optimus to climb all sorts of staircases, indoors and outdoors, wooden stairs, stone stairs, steep and shallow steps, so it's prepared for virtually any real-world situation. As confirmed after the Optimus dance video was released, Tesla continues to use advanced simulation environments to train the robot. This allows Optimus to go through millions of scenarios without needing physical testing. It's a method that saves a huge amount of time and cost, while pushing the robot's real-world accuracy to a whole new level. While going upstairs is a major achievement, going down is a much tougher challenge. Gravity pulls the robot's center of mass forward, and a single misstep could lead to a fall. Tesla has confirmed it's actively training Optimus to master this skill. The robot is learning to place its feet more carefully, keep its center of gravity low, and react quickly to maintain balance. Tesla engineer Milan Kovac also shared that the team is working on giving Optimus better vision so it can predict step position and shape with greater accuracy. This improved spatial awareness will help the robot anticipate risks and adjust its movements more naturally. Milan also didn't shy away from revealing that the Tesla team is developing a safe falling skill for Optimus. Sounds odd, right, but it makes sense. No matter how advanced its balance gets, unexpected situations will still happen, and like a human, Optimus might fall. The key is that it's being trained to fall in ways that minimize damage and allow it to get right back up afterward. One thing we can say with confidence: Optimus's balancing ability opens the door to real-world applications across a wide range of industries, each with its own demands for stable, reliable performance under different conditions. In a factory setting, Optimus can navigate cluttered spaces, carry heavy objects, or perform assembly tasks on uneven surfaces. Its ability to stay balanced ensures it won't drop materials or damage equipment. Just imagine the cost of a high-value component being dropped, or a machine getting damaged because the robot lost its footing. It could disrupt the entire production line and lead to serious financial losses. In the home, exceptional balance becomes even more critical. Whether Optimus is cleaning, assisting the elderly, or moving items around the house, its precision and stability need to be on another level. As a home helper, even a small mistake could shake user confidence and harm Tesla's brand image. Picture Optimus, constantly dropping and breaking dishes, knocking over decorations, or worse, accidentally injuring someone in the household. It's not just about the material damage, it's about trust. In a living space where safety and finesse are essential, a robot without reliable balance isn't a helper, it's a liability. And if Optimus can't deliver trustworthy performance at home, the fallout won't just be broken glass, it could be a broken reputation. In high-stakes situations like disaster response, balance is just as vital. Imagine a robot maneuvering through rubble, climbing hills, or crossing slippery terrain during a rescue mission. A robot that can stay upright and move steadily in chaotic conditions isn't just faster at reaching victims, it also avoids becoming a hazard itself. The last thing rescue teams need is a robot toppling over and getting in the way. In life-or-death moments, the difference between a robot with good balance and one that's unstable could literally mean the difference between success and failure. In space exploration missions or military applications, robots must operate on rugged planetary surfaces or in high-risk zones. A strong sense of balance is essential for ensuring that these machines can complete tasks without constant human oversight. The Optimus Gen 2 is equipped with a 2.3 kilowatt-hour battery, enabling it to operate for roughly 8 hours per charge, enough for a standard factory shift. However, battery life varies depending on the nature of the task. Energy efficient, stationary operations may extend uptime, while power-intensive activities like walking or lifting heavy loads will reduce it. The improved balance capabilities of Optimus, especially in the Gen 2 model, play a key role in enhancing energy efficiency. Thanks to advanced AI and sensor integration, Optimus can maintain stable posture on uneven terrain, squat and rise smoothly, and even balance on a single leg. These advancements reduce unnecessary movements, enabling the robot to use less energy when performing complex tasks. A lightweight design, utilizing materials such as plastic and carbon fiber, along with a capped energy draw of just 500 watts, helps optimize power use across its actuators, extending battery life without sacrificing performance. Elon Musk recently confirmed that Tesla is building a dedicated production line with the goal of manufacturing 1,000 Optimus robots per month. However, the timeline has been delayed by several months due to notable supply chain challenges. As of April 2025, Tesla is facing bottlenecks in sourcing rare earth magnets from China. These shortages are tied to strict export controls imposed by Beijing over concerns about potential military applications. Although Tesla has emphasized that Optimus is designed solely for civilian use and is actively negotiating to obtain export licenses, no breakthrough has been reached, slowing down production plans. Additionally, the supply chain for Optimus, comprising thousands of new components, including actuators and specialized electronics, cannot be supported by Tesla's existing automotive infrastructure, adding another layer of complexity to scaling production. Nevertheless, Tesla's proven ability to overcome manufacturing bottlenecks, as seen during the production hell of the Cybertruck, and its in-house technological development expertise, suggests the company is well positioned to tackle these hurdles. Tesla is expected to host small-scale production line tours for investors in Q4 2025. According to Elon Musk, numerous Optimus humanoid robots are already operating 24/7 within Tesla offices without any human supervision. These robots are even capable of autonomously recharging their batteries when needed, highlighting Tesla's rapid advancement toward a highly autonomous future in humanoid robotics. Another intriguing highlight is Musk's confirmation on X. "I will have an Optimus dance troupe on stage with me at the Tesla shareholders meeting." This points to a new impressive live demonstration of Optimus that is likely to take place at a major event next month, similar to previous years. Coinciding with this, Tesla is also expected to officially launch its robo-taxi service, Cybercab, marking another milestone in the company's autonomous transportation strategy. In summary, Elon Musk envisions Optimus as the machine that brings AI into the real world, where humans can coexist with robots without the dystopian overtones of Terminator. Musk emphasizes that Optimus will understand you, with the ability to customize its personality, voice, and preferences without the need for explicit commands.
Yeah, you'll be able to customize the personality, customize the voice, and really kind of the robot will kind of get to know you as well and know your preferences. You won't even have to say things because it'll just kind of understand you.
He believes Optimus, capable of learning from video and performing a wide range of tasks, will shape the future of humanity. Musk has even predicted that the Optimus market could reach a staggering $25 trillion, surpassing any product in history, underscoring his deep conviction in the robot's transformative potential. For Tesla, Optimus represents a core driver of long-term growth, with potential to eclipse even the company's electric vehicle revenue. Hundreds of Optimus robots have already been deployed at the Fremont factory to handle basic tasks, and Musk expects production to reach at least 5,000 units this year. He revealed that initial manufacturing will begin at Fremont by year-end, with expansion plans underway for the Austin facility. With a target price of $20,000, Optimus leverages Tesla's full self-driving AI, the Dojo supercomputer, and deep expertise in electric motors and gearboxes to cut factory labor costs by 30 to 40%. Mass production aiming for millions of units per year by 2030 will open up applications in logistics, household services, and even healthcare. Optimus promises to reshape labor and society. With its ability to perform tasks ranging from simple to complex, it has the potential to replace humans in dangerous or repetitive jobs, thereby boosting global productivity. Elon Musk envisions a future where the robot-to-human ratio reaches 1-to-1, equating to 10 billion robots serving both personal and industrial needs. However, this vision brings with it significant challenges. A new supply chain must be established to support the production of essential components like actuators and sensors. At the same time, the threat of widespread job displacement underscores the urgent need for robust regulatory policies and workforce transition strategies. If successful, Optimus could embed AI into nearly every aspect of human life, ushering in a new era of technological and economic transformation. The usefulness of humanoid robots might still seem vague to most people around the world, but their future, that's anything but unclear. At Tesla, the Optimus robot is no longer just some high-tech gadget. It may sound hard to believe, but this robot is going to change our lives forever. Not just in the US, but globally. Sounds far-fetched and maybe even a little ridiculous, right? We get it. We used to think the same way. But after more than a year of following and analyzing Tesla Bot, especially with the company's recent updates, we're confident in saying this. Optimus is going to be a game changer. The benefits it brings will be so massive that people will be scrambling to get their hands on one, even if the price ends up being a lot more than the $20,000 Elon Musk originally promised.
I think Optimus is going to be incredible in like 5 years, 10 years, like mind-blowing. And I'm really interested to see that happen, and I hope you are too.
In about 5 years, you could spot a Tesla Bot anywhere. Tesla factories, city streets, parks, convenience stores, malls, hospitals, or even chilling next door at your neighbor's place. That's exactly what Elon Musk is gunning for, and it's why he's not shy about pouring tens of billions into this robot. He knows Optimus is the fast track to turning Tesla into a $25 trillion company. Just recently, Musk dropped another hint on X, saying, "So many improvements to come in the next design of Optimus," basically confirming that Optimus Gen 3 is right around the corner. From what we've heard, Gen 3 is going to be a massive leap from Gen 2, packed with some seriously wild features as Tesla's final commercial version. So, what's inside the next-gen Optimus? Tesla's come a long way since they kicked off the Optimus project back in August 2021 with that first goofy reveal of a dancer in a robot suit. That's how it started. And look at it now. A huge leap in just a short time. When you look at the rough Optimus prototype Tesla unveiled in September 2022 and compare it to what the Tesla team has pulled off in less than 3 years, it's honestly mind-blowing. Since then, Tesla's been dropping occasional video updates on Optimus's progress, and it's been impressive the whole way. But when Optimus Gen 2 dropped at the end of 2023, things went from impressive to straight-up game-changing. That release was the start of a massive bet, with Tesla, Elon Musk, and even customers clearly buying into the Optimus vision like never before. Gen 2 didn't just look sleeker and less clunky, it came with a slew of performance upgrades that turned heads. Before we dive into what's coming with Gen 3 later this year, let's recap those Gen 2 upgrades. First off, Optimus Gen 2 moves 30% faster thanks to weight optimization, shedding 22 pounds, which makes it more agile and energy efficient. Its feet, designed to mimic human ones with force torque sensors, boost balance and let it glide smoothly over rough terrain. The real showstopper, though, is the hands upgraded to 11 degrees of freedom from just 5, with tactile sensors on each finger. This lets Optimus do delicate tasks like holding an egg without breaking it, folding clothes, or sorting colored blocks. Plus, the neck got a boost to 2 degrees of freedom, giving it human-like head movements to scan its surroundings better. On the hardware side, Tesla packed in custom-designed actuators and sensors, plus optimized electronics, delivering top-notch precision and reliability. The overall design is sleeker, with smoother, more natural movements that ditch the stiff robotic vibe of Gen 1. On the smarts front, Gen 2 uses neural networks and 2D cameras to navigate indoors without GPS, recover from slips, and handle tasks like assembling parts in Tesla factories or serving drinks, though some actions still need remote assistance. Here's the thing. Building a humanoid robot is 5 to 6 times tougher than churning out a regular electric car, especially since Tesla's only had less than 2 years of experience with this tech. The challenge breaks down to about 30% manufacturing and assembly, and a whopping 70% integrating AI into Optimus. Speaking of assembly, Optimus isn't too different from the Tesla Semi. About 60 to 70% is hand-built by a dedicated team of engineers, not cranked out on an automated line like Tesla's other vehicles. Now, let's talk about what's coming with Gen 3. At first, we thought it might drop late last year after Elon Musk posted on X in July, saying, "The new Optimus design, which will be complete later this year, is something special." That got us hyped for a year-end reveal, but it didn't happen. Musk might have been a bit too optimistic there. In November, he admitted on X, "The toughest part by far is improving the design of Optimus for ease of manufacturing and tooling up a complex supply chain, so it can be made in significant numbers." So Gen 3's new design is likely being reworked to balance aesthetics, cost, and large-scale production. We're not saying it'll look cheap. Think of it like Tesla's EV refreshes. It'll be better designed, more efficient, and appealing to buyers without jacking up production costs, setting it up for major market success. Another important upgrade that only Optimus Gen 3 has is the 22 degrees of freedom hands, double the 11 degrees of freedom in Gen 2.
If you want to have a humanoid robot that can do things that a human can do, it's a very high bar. So our new arm has 22 degrees of freedom instead of 11.
Our next generation has 22 degrees of freedom. It will be able to play the piano. So it's really like, wow.
As we know, Tesla has repeatedly shown demos of the next generation of Optimus's new hand, a completely redesigned key component that allows for more complex actions, is waterproof, and has more sensors. The new hand completely covers the actuator and some of the wires, instead of leaving them exposed, like in the Generation 2 version. Tesla has chosen the hands as the technical focus of the Optimus robot. Musk believes that these hands will create a huge gap between the Tesla bot and its competitors, and can become the most sophisticated humanoid robot in the world, performing 100, 500, or thousands of different tasks. Our hands have 27 degrees of freedom, and we can do any job we can with them. With 5 flexible fingers, hundreds of sensory nerves, and extremely sophisticated mechanical structures, the human hand is the perfect tool for creativity, labor, and intellectual expression. Therefore, creating a machine that can simulate the flexibility and sophistication of the human hand has long been an ambitious dream in the robotics industry. A hand with 11 degrees of freedom has now been increased to 22, which is only 5 degrees of freedom less than a human hand. Simply put, the 11 degrees of freedom hand has allowed Optimus to fold clothes, water plants, hold eggs without breaking them, install electronic components, carry battery trays, and even serve drinks. That's just the beginning, because both Optimus's brain and hand are still quite primitive. But that makes us even more curious about how sophisticated a 22 degrees of freedom hand would be. Another improvement that will make Optimus more mobile and flexible in the upcoming Gen 3 version is the speed of movement. If you look at the gait of humanoid robots like Boston Dynamics Atlas, Unitree, or Kepler Forerunner, you will see that they all have a slightly bent knee gait, similar to Tesla Optimus. In fact, this design is not accidental but due to technical requirements. When the robot is in a bent knee position, the center of gravity will be lowered, thereby increasing stability and making it easier to maintain balance when moving. But it seems that most people do not like Optimus's gait. It is often compared to Joe Biden's gait. Therefore, the speed of movement will be improved to help Optimus move more naturally when Elon Musk once revealed that they would remake Optimus's hardware.
And I think we've got kind of like one major hardware revision, which should be done by end of this year or early next.
Right now, Optimus moves at just 1 meter per second. That's about 2.2 miles per hour. Yeah, it's still a long way off from Tesla's target of 5 miles per hour. They might not hit that goal anytime soon, but there's no doubt Gen 3 will see improvements over Gen 2. This slow walking speed could be a drawback when it comes to real-world usability, especially for most buyers, including us, who prioritize a robot that can move more fluidly. And it's not just about how fast it walks. It reflects the overall performance of its joints, drivetrain, sensors, and even battery coordination. All of those systems have to work seamlessly to create a robot that's not only functional, but truly practical. With Gen 3, we bet it will surpass humans in many aspects as it can operate non-stop 24/7, eliminate human error, ensure high precision, minimize labor injuries by handling dangerous tasks, and flexibly adapt to many different roles in manufacturing thanks to advanced AI and machine learning capabilities. You know, Elon Musk has emphasized many times that Optimus can watch YouTube and learn new tasks from that video.
If Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly.
Because of this ability, its potential seems limitless. It can learn anything through just one video tutorial, a robot that knows how to cook. That data will be uploaded to 100 other robots, which is how Tesla expands the number of tasks for Optimus without having to train each robot individually. The reality is that Tesla's humanoid robots will need to become part of the workforce, and businesses that want to stay competitive will need to take advantage of the core cost-saving benefits that this robot brings. How will the Tesla bot save money? Before we show you the evidence that Optimus can become a real cost-saving machine, let us know your opinion by leaving a comment. If you had $25,000 to $50,000 in hand, would you buy a Tesla bot or a Tesla EV? From a consumer perspective, we would be more willing to choose the Tesla bot, even when placed next to impressive models like the Model Y, Model 3, or the upcoming low-cost car. The reason is simple. If a robot can work efficiently and help you generate income, why not invest in it? While Tesla EV are mainly used for transportation for a few minutes to a few hours a day, and most of the time they are parked, Optimus can work continuously for 8 hours a day or even more. It would be great if you could own an Optimus robot to deliver goods, produce, craft, or perform other profitable tasks. Thereby, the cash flow you generate from the robot can continue to be reinvested to buy more robots, maximizing profits. In this way, the robot can pay for itself, and in the long run, you can even use that profit to buy a new Tesla EV. According to some of our analysis, the potential cost savings from using Tesla bot can be as high as $83,000 per year, with a payback period of just 3.7 years. This is an attractive investment for large households, commercial businesses, or factories. The biggest advantage of the robot is its ability to work up to 7,000 hours per year, far exceeding human labor productivity. In case you can't afford to buy Optimus, how about monthly or yearly rental options? Elon Musk once announced on X that bots would be offered both as rentals as well as to buy, but the former first. In our view, leasing makes a lot of sense for Tesla, as it is an effective approach to reduce the burden on both Tesla and customers when Optimus first launches. First, it is easier to track and handle issues that arise. The leasing plan will first be rolled out internally to Tesla employees in 2026, and then gradually expanded to customers as a form of real-world market testing. Leasing will help Tesla collect valuable data on how robots are used in the real world, which can then be used to improve the design and capabilities of Optimus.
I think we have to be careful about Optimus being potentially used in ways that are bad, because that is one of the possible things to do.
Even Elon Musk has admitted that AI is more dangerous than nuclear weapons, and he has pledged to approach AI responsibly and not create a Terminator or iRobot version like we often see in the movies. However, that said, 70% of the challenge with Optimus lies in the complexity of the AI software that is built into it. AI is not simple, especially when it is integrated into a humanoid robot. In the event of a bug or software glitch, it is entirely possible that there will be risks. Even Elon Musk has admitted that Optimus will eventually have some minor bugs in the early stages of its launch, saying,
That, because it's probably have a few bugs, but it's going to be very cool. You'll want to invite your friends over and say, check this out.
So, leasing was originally intended to keep maximum control over the technology for safety reasons. By leasing Optimus, Tesla can retain control to prevent the robot from being misused. This is important for both security and intellectual property rights. In addition, leasing also makes it easier for Tesla to update the robot's software and hardware whenever a new version is released. This means that the lessee always has access to the most advanced technology. Ultimately, the decision to lease or sell Optimus will depend on many factors such as production costs, market demand, and Tesla's business goals. They can also offer both at the same time depending on customer needs. As we all know, Elon Musk is still the richest billionaire in the world, and this position is due to his continuous efforts and tireless work hours, 120 hours a week for 6 companies. Elon Musk is always considered as a person from the future because he's a super accurate vision. Musk will not invest or spend money even $1 on projects that are not feasible. This sounds different from reality because it is clear that humanoid robots have never been a lucrative field until now. Almost no company can turn the machines in the research facility out of the lab and commercialize. Skepticism and contempt for humanoid robots is more than trust in them. However, Musk still chose to invest in humanoid robots because he believes Tesla has enough resources to build a humanoid robot. However, it should be stated that Tesla will not sell Optimus robots this year. The robots produced will be mainly used in Tesla factories. This means that thousands of robots will be deployed in production lines, warehouses, and various departments in the factory. Tesla's goal is not to maximize profits or replace workers with Optimus robots. This is completely wrong. Now, it is not important to know which humanoid robots are leading, but it is important to know whether these machines are actually useful to humans. Can they assist humans in basic tasks, or are they just expensive moving toys? Yeah, everyone wants to own a versatile robot that can help with all the boring housework. As recent updates have demonstrated, Optimus, trained with a single neural network that learns from videos of people, has shown remarkable adaptability. The robot is not only aimed at factories but also at homes, where it can alleviate daily tasks. As the world faces labor shortages and the need for more automation, Optimus offers a practical solution. Upcoming improvements will take it even further, transforming humanoid robots from a concept into an essential reality, allowing humans to focus on what really matters: creativity and connection. You might be wondering why many people think the price will be higher than Elon's $20,000. The simple reason is that humanoid robots already provide tens of thousands of dollars in annual usage value. Although the Tesla bot Gen is coming later than expected, this will allow this version to reach a higher level of maturity, integrate new features, and ensure more stable performance than it is now. Tesla still needs time to optimize the technology and improve practicality. Rest assured, this is just the beginning. When you have Optimus in your hands, it will be completely autonomous.